Hello, everyone. Thanks for joining our talk. My name is Jeremy Udit, and I'll be joined by Keegan Campbell, and we'll be going over what it's been like to maintain GitHub's Terraform provider. Starting off with some introductions. So I've been at GitHub for about 4 years now. I originally started out in the infrastructure org and primarily working on data center automation, so taking care of our bare metal virtual machine and containerization resources. I've since moved on to more of a product focus, and I'm maintaining our GitHub Pages product. As for my involvement with the GitHub Terraform provider, I've been maintaining this project over the past couple of years. I had originally gotten involved through my work with HashiCorp to deploy Terraform Enterprise internally at GitHub, and during this time, a maintainership position was offered. I remember thinking back on that, and I figured it was a good opportunity to grow my understanding of GitHub's products, APIs, customer experience, and just overall understand what it's like to be a maintainer of an open source project. And I figured it would be a good complement to my existing infrastructure focus. Overall, just wanted to volunteer time to ensure the quality of this interface to GitHub stayed high. And now Keegan will give a quick introduction as well. All right, so let's get this talk started. We've got 4 different themes to cover. First off is community, then we'll lead into testing, implementation, finally releases. Starting off with community, we'll cover topics like what it's like to inherit a provider, speak a bit about project governance, contributor onboarding, and round out with how we deal with opposing customer use cases. So this project started out within the HashiCorp GitHub organization, and contributions and support were mainly from HashiCorp engineers. And this was great because most popular use cases and resources were already implemented and being used. So things like repositories, teams, branch protection, anything that you'd want to configure for your team within a GitHub organization was just there. And it was also great because the provider was being meaningfully used by HashiCorp and other organizations at the time. So there wasn't really much missing, and it was a very comfortable starting point as a new maintainer. And as mentioned, this was my very first experience in a role like this, and it led to some growing pains early on. So first off was learning how to triage and prioritize issues, and just in general, what it takes to tend to a community. So what to read, what to listen to, and how to best reflect and express the community's needs through next steps. Also had to learn how to manage my own time. It's definitely an investment, and the expectations of the community originally didn't line up with the expectations of my time. So it was definitely an exercise in setting a sustainable pace and getting a good rhythm going that matched what the community required and what I was able to give. At some point in time, we migrated the project away from the HashiCorp organization and into a GitHub-owned organization called Integrations. And as part of that, we ended up reshaping the project a little bit, as you can see here. So it was mainly just fitting to the GitHub open source mold, matching on licensing, README style, adding a support disclaimer in there. So pretty cosmetic, but overall the process took a fairly long time. It was quite low priority, and getting reviewers and approvals along the way kind of slowed things down. But overall, we got it out there eventually. And another slip up that was made there was just communicating the change better. So when it did happen, it was quite abrupt for some users. And we had to publish documentation retroactively instead of ahead of time to help the community adopt the new project location. So on to some stories around contributor onboarding now. So furthermore on the community theme, let's start talking a bit about opposing use cases. So we've definitely had some friction here, and I believe it's a reflection of the complexity it takes to ship a feature for a product within the GitHub suite. So GitHub has a lot of use cases that it covers, a lot of personas that it tries to address, and Now, some features only make sense for .com, so that's the GitHub.com deployment, and other use cases may only make sense for the enterprise deployments, and some are just shared and don't cause too much friction. Some features are only available to some subsets of accounts, so users versus organizations. And then there's also some features that are only enabled for specific plans or tiers of plans. And originally, the provider's feature set and testing and release process were very much geared towards a single type of use case, which was the GitHub Enterprise Cloud Customer. And that's a .com deployment with paid features. So over time, as shown in this issue, the community began raising red flags whenever a new release would come out. And their concern was the release would be incompatible with their version of GitHub Enterprise Server. So this raised the call for better messaging around feature compatibility as things went out. And thankfully, the call was partially handled by the community. So it's great to see the community chip in and offer reporting, working solutions whenever there's ambiguity on whether or not something would work. And it's one of those things that really helped at the time. I think even to this day, we don't have very good testing around the full suite of enterprise server offerings. So it's just a very big thanks whenever someone can share their story and their experience with a specific version, and just give people a heads up and save them some time whenever an issue jumps up. Moving on to the users versus organization tug of war. So originally we had good support for organization accounts being managed by a full token or token with full admin scopes. And we've since grown out of that specific use case, and really has been driven by the community. So this example shows how we've added anonymous support, and just in general, growing different use cases has led to friction in the past due to changing code that wasn't very well tested. And got a couple of other examples here. Here we show a regression that was added when we made a change to our most common authentication scenario. So just the organization authentication method. And then we've tried to move away from that and abstract just organizations and individual users behind something called an owner. And by implementing that, it wasn't very well tested, and we ran into some detection issues whereby an owner was interpreted as a organization instead of a user. But those rough edges have been smoothed over, and yeah, it's a really good example of how someone can be affected because of how a product is being used in a use case that is completely different from their own. And that rounds out the community section. So let's move on to testing. So as for acceptance testing, we started out with a private Team City instance, and this was a resource managed by HashiCorp and used internally there. So I found that it had good highlighting of where and when a build broke, and it was a good enough early solution, but very geared towards internal use. So it did require coordination to update secrets, as I had limited access, and there was no contributor access to the feedback that the system gave. So a lot of the testing results would have to get proxied back to the community through a maintainer. Eventually, we migrated to a dedicated GitHub action, and I'll show that right here. And this is primarily to provide contributors with a feedback loop for their changes and give maintainers better access to secrets management. Throughout the lifetime of this action, we've done things like add label-based runs. So at some point, we would be able to just pick a label from the PR page and add it with a specific prefix, and that would kick off a subset of tests. That evolved to detection-based runs, where you didn't really have to figure out the prefix you were looking for. The code would do it itself. And then we also added multiple test suites so that we would test against github.com deployments. And then at one point, we had a test instance up for GitHub Enterprise Server, but that just became too expensive to run. Returning the slides here, we also ended up shaping our test cases a bit differently from other providers. And our main focus was to make sure that we could test the documented HCL that would come along with a resource. So we made it so that we're not building up a string here, but instead just pasting in a block that we could paste into a Terraform config file and run it. And then we also made sure to address the different use cases explicitly and ensure that we could test against them. So another characteristic of our test code is it's highly duplicated, and the repository resource is probably the most amount of duplication. It just makes it very easy to add a new test, to not really couple tests together, and then also readability. It makes it a bit easier to understand what's going on within a single test. So uh, there's not too many of these files, but it definitely gets a bit hairy with the amount of duplication. Looking for a specific test can be a bit difficult, and we started to group related features in a single test. So that's helped, but overall it's quite verbose. And the final little pattern that we've also jumped into is investing in this examples directory. So this allows us to test bugs that may be very difficult to exercise through the normal testing route. And it doubles as documentation as well. So if there's any big new features that land, it's good to give possible users a nice working example to start off with before they jump into their own implementations. So that's that leads us into our lessons learned for testing. And I could say that we went through a period of just gaining confidence with the project itself via the tests. And this was early in my maintainership story. So the pace of releases ended up being traded off here as I was investing in tests. So it was kind of a time bound effort, and it was a good learning experience to scope out the level of investment that was needed to keep tests stable and usable. But we ended up scaling back investment on testing and just relying on documentation. So getting strong contributor documentation on how to run tests locally and set up a proper testing environment was kind of the pragmatic choice to keep the project afloat and moving without investing too much time in keeping tests alive. Some other little tidbits of knowledge. Tests are written with an understanding of them not being free. There's a reliability cost to it, mainly due to API limits and such, but we try to just add tests that cover most important and used use cases, and just want to decrease the probability of introducing bugs, but not make it zero. The investment to make it zero might be a bit too much, and it tugs on reliability of the test suite as well. This is definitely not where the project wants to be, but it's where we've settled with the amount of time afforded to it. So being pragmatic has helped us here. So with those lessons learned in testing, we can move on to the next section, which is implementation. All right, so following on along with the implementation theme, we'll discuss what it's been like to consume multiple versions of an API. So at GitHub, we've got a couple of versions. We've got the V3 REST API, as well as a new V4 GraphQL API. And the Terraform provider for GitHub had originally shipped with only REST implementation, which is great because it's a simple mapping to Terraform's CRUD style operations. But moving off of this over time became apparent as we had a couple of motivations. For one, features started to be released only to the GraphQL API, and some of those features were very highly coveted by the community. And then on the other side of things, the V4 API promised a more lightweight way of retrieving data, which has benefits for rate limiting. More on that later, though. So once we decided that we did want to pick up this new interface, we had a few different adoption paths ahead of us. there's some discussion around that, and one of the suggestions that came out from the community was to switch to a completely new provider or publisher, an additional provider with a beta suffix to it. So this would have allowed for complete separation between development of a new feature and graduating over to the kind of more stable provider that was in existence. We ended up upgrading just a single resource as a starter, and the resource that we chose was highly used, so it was fairly risky, but upgrading to V4 allowed us to get a highly coveted feature for GitHub branch protection. So it was the way that we pursued. So adopting the V4 API on a resource by resource basis is good for gradually adopting the new API and allowing us to evaluate compatibility, as not all resources perform the same. And just a quick look at the implementation. So we added multiple clients instead of overriding the additional one. So this allowed us to keep using the V3 client and pick up the V4 client for whichever use cases made sense. So all resources within the project could just lean on one or the other client, or maybe even both. So with that gradual approach and the flexibility and the implementation, we still ended up shipping a few regressions reported by the community. So after migrating our branch protection resource, we got a bunch of issues that came out of it. And as you can see here, there's issues with the overall runs being slow. And I think there was some functionality bugs as well. So shipping it gradually was a good idea, but we still ended up with things to clean up afterwards. So one of the tactics that we used was just to kind of roll forward, but also provide an option for people that didn't really need the new implementation, was to ship just a pinned V3 resource for GitHub branch protection that could be used by some community members. And this would allow them to move forward with all the other improvements within the project without having to wait on or fix their branch protection rules. All right, moving on from consuming multiple API versions, let's talk a bit about API rate limiting. So there's a couple of ways this affects the project. One is on the acceptance testing side of things. We have a limited throughput that we can get through because of the rate limiting that our authentication provides us, and that mirrors the same types of issues that users of this project face when they try to push through large runs of against their infrastructure. So rate limiting it's kind of just what you got to deal with whenever you're using cloud resources or really any resources, because there's always limits. GitHub has a limiting implemented as a shield for us, and it really helps us keep load predictable on our infrastructure and keep a shared utility up for everybody that needs to use it. In practice, using the API, you can expect that searching would be the most expensive operation, and then that would be followed by just like targeted REST calls that return JSON blobs, and that's followed by GraphQL queries that are very targeted as well to return an even smaller amount of data compared to the REST API. So some mitigations that we've added, I can show a bit of code here. So we added a rate limit transport early, like very early in the project, as I think the goal here was to make sure that Terraform runs would complete, and the sporadic errors that would get thrown back due to hitting limits in the API would be smoothed over through retries and inserting delays. So here's an example of how we inject delays during our write operations. I think this is just like a quick little sleep here, and we respect whatever GitHub recommends as our retry after value. And then for read traffic, we attempt to use caching best practices by leveraging the etag header here with the if none match directive. So in the best case scenario, we just get a 3 or 4 not modified response back from GitHub instead of a full payload, and that might help us out with our rate limiting budget. And we've also added the GitHub App authentication method for the provider, which has a better budget for API use. And throughout all of these efforts, we've received mixed feedback from the community. In practice, there's a fair amount of use cases that still stress the API rate limiting mechanism, and it happens enough that whenever new features are being rolled out, we should be reviewing for the impact on performance and really actively trying not to do too much with the API or be as efficient as possible. Just a quick example of things that have popped up in the past. So here we see that our GitHub repository file resource has suffered from limiting in the past as well. And it's a good reminder that the mitigations that we do have in place, they're not one size fits all. We definitely could benefit from exposing tuning of this mechanism, as some users are able to just crank up the parallelism, and they just don't have a ton of resources to manage. So they'd be able to really speed up their runs without having to go through the best practices that GitHub recommend. So that rounds out the implementation section and types of things we've had to battle over time. Next, we'll move on to releasing. All right, so continuing on with the releasing theme, let's talk about tooling and how it's grown up over the past couple of years. Originally, when picking up this project, the workflow was to ping in a shared Slack channel, and other provider maintainers were there, as well as HashiCorp folk. And depending on the day of the week and the size of the request, maybe you'd get your release out the same day, but so there'd be definitely times where there'd be nobody around and you'd want to push a release, but you needed that coordination. So it was definitely something that was a pain point for the operators of the process, and maybe a little bit for the consumers of the process. And it definitely was an unscalable way to trigger releases. So HashiCorp began working on better automation through the Terraform registry. And just a quick visual here. This is what we ended up with. Here's our provider on it. And you can see that there's good documentation integration with it. So overall, I think this was a great success. Adopting it was a little bit rough for us, but getting onto this tooling has really helped us out with our rate of releases and our ability to size releases. Another benefit of working within this community has been receiving communications of the best practices for the provider community. So in this example, an issue I think was open in various providers to adopt a new target, a build target that moving to the latest release of Go had unlocked. And staying up to date with that kind of stuff, it's not something that I personally have a ton of time to do. So I really do appreciate it when this type of information comes up into my existing channels that I watch. So this just showing up as an issue in the Terraform provider GitHub repo was great. And I really appreciate that these community-wide efforts get spanned out to our individual projects. So tooling has definitely been upgraded over the past couple of years. And to go along with that, I think it's unlocked our ability to change philosophies around releases. So I remember early on having to dig through just a large release to go and find out what breaking change was in there, or what commit broke a specific use case. And being able to advance in release tooling has allowed us to ship smaller and more frequently. And on the flip side, that also allows us to isolate risky changes, so that if something is going to go out that maybe wasn't well tested, or there are willing testers out there that just want to play around with it, we can just ship a small release now and and really shield people from large breaking changes that are very difficult to backtrack from. Another thing that we've tried is bundling related changes. So our project tracker makes use of labels fairly well, and we label our issues by resource. So we have a pretty good understanding of which resources are lacking and where. And the goal there was to uh, ship releases based on resources so that we could uh, tackle things without context switching too much, or maybe provide some type of wholesale change that fixed multiple issues at once. So that was the aim, but it worked well for the small resources. Over time, we just ended up uh, continuously getting very random contributions and PRs, and we switched the aim to just kind of keep the queue moving. So instead of dictating what would change, just be responsive to whatever showed up and tried our best to batch them up. And I believe our improvements to contributor documentation might have helped increase the rate at which PRs were showing up, but who knows, it could be just more adoption as well. Um, so yeah, and I think that's the current state of our philosophy to this project is just keep the queue moving. We don't want to unnecessarily block momentum. Even if we ship something that's not really ready, it'd be quite easy to test things out and recover from it with our increased ability to ship. So keeping the queue moving is definitely what we've settled on nowadays. And the very final thing is just staying humble and empathetic. Um, I'm super glad to have the opportunity to grow as a maintainer, and I'm really appreciative of the community's patience as this has gone on. And on the other side of it, it's just being empathetic to various use cases. This is a shared provider. It's got a lot of different uh, environments to work in. And just being flexible to all of those needs is really important, as we're not trying to exclude any uses of GitHub. We have a fairly flexible product that we have to give access to. So staying responsive is very important as well. And with those learnings I'm releasing, that can close out this section and most of the talk.
Hi, I'm at KF Campbell or Keegan Campbell, and I'm a software person at GitHub. I work on the Frameworks for Services team, which means I'm primarily working on internal tooling for Go and Docker, as well as getting loaned out to various other product teams periodically. I've been in GitHub for a little over a year and 8 or 9 months or so. I got started working on the GitHub Terraform provider when Jeremy put out a call on an internal Slack channel for people who wanted to write Go code for fun, I don't know, about 6 months ago, and it really has been a fun experience. In general, I'm knowledgeable about Go, Docker, and Azure Resource Management. Let's talk about our contribution model on the GitHub Terraform provider. The provider's project governance is an interesting situation. We are not paid to work on it, and we don't really get reserved work time for it either. We just happen to work at GitHub, use the provider, and care about others in a similar position. We've taken the stance here that our maintainership is primarily centered around nurturing the community rather than being drivers of specific changes ourselves. In practice, this means the majority of our time is spent reviewing, testing, and merging community PRs. Our goal is to balance safety and stability with an openness to contributions that benefit a wide variety of use cases. In order to grow involvement with project stewardship, we've primarily looked internally to Hubbers who like to write Go. We've established our own Slack channel to foster communication separate about the provider, separate from general Terraform discussion at the company. And we've also scheduled a recurring get-together to discuss the project, pair on code reviews, team up to tackle bug fixes, and talk about feature requests from customers. As I've mentioned, most of the new feature code is provided by users of the provider, and the door is always open for new contributions and contributors. One thing we have tried to take advantage of with the Terraform provider is that onboarding new contributors is a great opportunity to improve the state of your service's documentation. When anybody is taking the time to learn your project and is starting from fresh eyes, you can do like we did and easily use that effort to make it easier for the next person in their position. Let's talk a little bit about testing the Terraform provider. When I think of types of testing for a project, I tend to bucket them into either unit tests or acceptance tests. Terraform's plugin testing overview, as you can see here, references both unit tests and acceptance tests, but spends far more time discussing acceptance testing. Terraform's testing patterns documentation deals only with acceptance tests, as they comprise the bulk of any provider's testing strategy. We make every effort to adhere to the recommendations given there and provide standardized test helpers to use, which Jeremy will talk more about in a moment. In general, for our provider, unit tests tend to not be super relevant unless they're testing the functionality of some sort of helper. We tend to test most behavior with what we call acceptance testing, but is also known as functional or integration testing. We require these kinds of tests for all applicable functionality that is introduced to the provider. Manual testing of added or changed behavior, which is a type of acceptance testing, you could argue, generally accompanies a change as well, but is not as specified. Maintainers and contributors should exercise the affected workflow with several different parameters as applicable when validating their changes, both in acceptance testing and manual formats. Now, there are a couple of interesting things about our testing strategy that are specific to the GitHub provider. For starters, GitHub has a couple of different products the provider works against. Regular GitHub, which is what we call .com, as in github.com, as well as both managed and self-hosted variants of GitHub Enterprise exist. It's not required to be an employee to work on the provider or test against enterprise instances, but it definitely helps to be able to access internal tooling to be able to spin up these instances for testing. Another interesting thing is that there are multiple different ways to authenticate to GitHub. As you can see here, we can have anonymous users performing read-only actions, user personal access tokens, and GitHub app authentication for each type of client that we use. Any of these methods can perform actions on a user's content or an organization's content. Because of these complexities, we occasionally run into bugs or obnoxious trade-offs about authentication fallback. Jeremy will take over now to talk a little bit about the way in which we've managed the orchestration of our test suite runs. The joy in implementation might be my favorite part of the product and software in general, really. And we'll talk now a little bit about some of the fun and interesting challenges we've had in the past with the provider. In general, we'll discuss three main pieces: tactics for smoothing over the rough edges of an API and fitting them into Terraform's plan, apply, and destroy pattern, consuming both GraphQL and REST interfaces, and we'll discuss problems with rate limiting. Now, Terraform's primarily plan, apply, and destroy pattern fits some types of resources quite well and some types of resources not well at all. As an example, let's consider the pull request feature, which you can see was first proposed here in October 2019. Now, how should we treat a pull request on this project? The data is kept around indefinitely by GitHub in a close or merge state once the pull request has been dealt with. Should we offer a pull request resource with a status that tracks created or merged, along with exact attributes to specify the content at each commit, like is proposed here? We ended up going another path instead, which is more oriented around declaring a pull request on top of a repo, as you can see here, with a repo and branch as base references, and then providing only a title and body at creation time and letting the repo attribute handle all of the actual file changes. Another challenge we've dealt with recently is working around archived repositories. In that case, the problem statement is basically, given that GitHub allows both deleted and archived repositories, what should the action taken be when Terraform destroy is run? Do we destroy or archive your repo? The approach decided upon was adding an archive on destroy flag to the repository object, which the provider can then use to determine the desired action to take for Terraform destroy. We've also seen, and here's an example of that archive on destroy flag from the pull requests. We've also seen some friction with GitHub repository visibility options. The valid states for GitHub repo visibilities are public, which means anybody can read your code, issues, and PRs, but write access is managed by the repo admins. There's private visibility, in which only the repo admins and those they delegate access to can read or write to the repo. And recently is a new feature called internal visibility, which is an organization-only concept that gives your organization members read-only access to the repo by default. We've had several bugs as a result of this feature, notably issue 580. In general, sometimes peculiarities of Git or Git constructs require us to be creative with the provider in order to neatly convert HCL files into GitHub resources. That is one of the more fun and challenging parts of being a maintainer. Another interesting facet of life for the provider concerns the API versioning that we are dependent on. Let's talk for a minute about releasing new versions of the GitHub Terraform provider. Specifically, we'd like to go over a typical lifecycle of a feature, the evolution of our release tooling, and the evolution of our release philosophy. Most frequently, feature requests come in via GitHub issues, and usually the community proposes fixes in the form of PRs as well. Frequently, contributions come initially with less testing than we really want, so that's a common request or contribution from our side when reviewing and shipping PRs. As a group, the team that maintains the provider meets up once every other week, but may respond to issues and PR feedback more often, especially since we're working in GitHub all day. A typical workflow might begin with the user of the provider opening an issue and later providing a PR to resolve their or another's issue. As a team, we will review the PR and go through some testing scenarios together, and occasionally this will include using multiple versions of a GitHub Enterprise product in order to make sure we don't break features for our enterprise customers. Now, one of the external factors that can limit our rate of feature adoption is the API support. You'll notice that of the two main Golang GitHub APIs, Go-GitHub and GitHub v4, which is the GraphQL client, Go-GitHub is the REST client, neither of these are owned or maintained by GitHub. We're in sort of a weird position this way, in which we work on the underlying project, which is then built upon by other folks, and then we use that platform to build our Terraform provider. Because of this, we occasionally have to wait some time after a feature launches on GitHub in order for the new API to gain support from the wrappers we use before our Terraform provider can adopt it. Once the team has reviewed the PR and the acceptance testing is in an appropriate place, it's time to pick an upcoming release, which Jeremy will talk about more in a moment, and ship the new code. In our session today, we've talked a lot about what it takes to maintain the GitHub Terraform provider. We try to foster community with a project, governance, and developer onboarding strategy that is focused on contributions from users of the provider. Occasionally, this means being forced to reconcile opposing customer use cases, and we've experienced some growing pains learning to be a dependency for others. Our testing strategy on the provider has evolved over time, and we attempt to adhere to HashiCorp's best practices when Terraform testing. GitHub-specific behavior, such as various enterprise flavors and authentication types, complicate matters a bit more. In our implementation section, we discuss tactics for smoothing over the rough edges of an API, consuming GraphQL versus REST interfaces, and rate-limiting challenges. Together, we've examined our release strategy, the life cycle of a typical feature, and the evolution of both our release tooling and release philosophy. Jeremy and I would like to thank you for coming out today. If you have any questions or comments, we'll be around virtually after the talk, or you can reach out to us on GitHub. Again, I am at KF Campbell, and Jeremy is at JC Udit. Thank you again, and I hope you all have a nice day.